We wanted to do something that was still within the spectrum of electronics, but something we hadn't covered in class, so that it would be challenging for us, something interesting.
Okay, well maybe you can show me how it works.
Certainly. So our project has two main parts, a master and a slave side. The master side is the side you can see here. It's got an LCD displaying the different sensors that our project entails. It's basically a control system. This would be the side that you'd see in a main office or a tower of some sort, where a person would be monitoring systems that would be down on a factory floor or something to that effect. So we've got air pressure, water depth, light, and temperature being displayed here, and the units that would be associated with them. There's three different modes the project can work in: master on, master off, and automatic. Like I said, it's a control system, so you can always have the control system over the sensor. Like for temperature, we have a fan, always on, always off, or automatically updating depending on the temperature that it's reading. Okay? So we have different switches to control the different modes over here. When you press this button here, it interrupts it and sends it out across the laser through to a photoreceiver on the other side. So on this side, the signal is received and it's sent through here back into the microcontroller we're using, which is a PIC16F877, and then it has control over these different sensors. So for example, you can manually turn on the light, or you can turn off the light. You can also have an automatic mode where on this sensor, if it falls below a certain level, when you cover it up, the light comes on. When you take it off, the light goes off. So it's like an emergency system for if the power goes out, something to that effect. Same thing with the fan. It's an automatic mode, or it's manual on right now, so it's always running regardless of the temperature. And another system I want to show you here is the air pressure system. So it's on right now. It's set to off right now. When Tim turns it on over on the master side, it's going to start sending the air pressure through. When the level gets above 100, then it's going to shut off and let it leak out until it falls below, turn it on again to maintain a constant pressure. Tim? Okay. So now I have to shut it off, Tim. So we have these three modes we've been talking about, and right now this is in manual off. Okay? So this will never come on unless, say, power goes out, something wrong happens on the master side, some unforeseeable event, and the beams get distorted, something goes wrong. At any rate, the beam gets interrupted. What happens is the entire system goes back into automatic mode. Tim, you could shut that off. So this way, if anything wrong happens, the system does not destroy itself. Say the air pressure is constantly building and you're blowing it into a tank, right? You don't want this tank to explode. So that way, the system maintains control over itself as well.
So do you see any commercial viability for your project?
Yes, a couple of different scenarios we could see it in. One that we've designed it for currently would be in a factory, right? So it's an industrial control system. It's monitoring presses, it's monitoring temperature, it's monitoring radiation, right? You can swap any of these sensors out, put new control systems in very easily. It's very adaptable. So what we want to do is make sure that it's as broad a spectrum that can be covered as possible. The reason we could see it in that kind of industry is because the wireless signal that would be coming out of a regular, say, router or anything else that's radiating electromagnetic signal, it takes about 1,000 times the power that the laser does. So if you want to go a meter with radiated electrical signal, you're going to be able to go 100 meters or 1,000 meters, right, with the laser. So just a 5 milliwatt laser, which is very low power, is going to be able to go 5 kilometers.